A cuboid is a 3D shape with the dimensions as the base here, the length represented by L, and this dimension here, the width represented by W, and the up distance here is the height. Now to find the volume of this cuboid, you will need to multiply the length with the width and the height. The length times the width times the height. So this is the relationship you will use to work out the volume of a cylinder. So I'm going to put this right now in a cloud, okay, because I want you to always remember this formula: the length times the width and times the height. Okay, so we're going to take a good question in the next slide. Okay, we'll take the first question and then we move straight. So the first question here, we have a cuboid with a dimension, the length 5, the width 3, and the height 4. To find the volume, all we need to do is to multiply the length by the width and the height. The length by the width and by the height. In this case, the length is 5, multiply the width, which is 3, of course multiply by the height, which is 4. And then when you multiply these three numbers out, you're going to have 60 centimeters cubed. We'll move on to the next question. We got a cuboid kind of flipped upside down or sideways with the dimension, the length 8.7 meters, the width 4.2 meters, and the height 3.1 meters. Again, to find the volume, all we need to do is to multiply the three dimensions, the length, the width, and the height. So we go the volume, the length times the width, and by the height. In this case, the length here is 8.7, so I'm going to put here 8.7. Multiply the width. Here the width is 4.2, so 4.2. Multiply the very height, which is 3.1. And then with your calculator, if you multiply these three numbers, you're going to have 113.274. Of course, because here is in meters, the unit, the volume going to be meters cubed. That was pretty easy, right? So let's move on to the next question. Now, in this question, it's a little different from the first two examples we've seen, because you see here in this question, we already know the volume of this cuboid, and we just know two sides of the cuboid, but one side of it is missing, which is the height. All right. So to solve this, all you need to do is begin out with the simple formula for calculating the volume of a cuboid, which you already know is the volume going to be the length times the width and times the height. Of course, we know the volume has been given to us in the question as 24,000 centimeters cubed. So I'm going to write down here 24,000, okay? And the length here given to us as 30, and then multiply this by the width, which is given us to us as 20. Now the height, well, we don't know what it is. In fact, that's what we're really looking for, right? So I'm going to repeat here as the height because we don't know what it is. Now let's see if we can simplify this even further. Of course, if you write this down with 24,000 or 24,000 really, 24,000 is equals to 30, and 20 will give us 600, and I'm going to multiply to h. Now to find the height, there are two ways you could do this. Either you think what number for height that will multiply 600 to give you 24,000, or you might just say 24,000 divided by 600. Either way you get the answer, but I'm going to do the simple way to divide 24,000 by 600 to know the height. So I'm going to do 24,000 here, 24,000 divided by 600 here. That will give me the height. And if I do this, I'm going to have 40 centimeters. So the height here is actually 40 centimeters. Okay, that's very simple. Now let's move on to one really difficult question here, because this is an exam style question. Now, a steel cuboid has a rectangular hole all the way through, as shown below. Now, this steel has a density of 8 gram per cm cube. Now, the question is, what's the mass of this cuboid in gram? Now, if you look carefully at this um, picture here, you find there is there's a big like call it a large cuboid, right? And there's a hole inside. And what you need to do to find the volume of the steel really is to find the volume of the big cuboid, steel cuboid, and then the volume of the hole and subtract. So let's begin by finding first the volume. Okay, the volume of the large cuboid. The large cuboid, okay? I think I just have to write it here so that you know which one I'm really calculating. So the volume of large. Let me put it this way. I like to put it more clearly. I don't want to make an assumption here. Now the volume of large cuboid, okay, can be calculated as the length times the width times the height. Here the length is 12, the width is 6, and the height is 7. Now if you multiply this out, you're gonna have 504 centimeters cubed. Of course, you can do that with a calculator or mentally. Next, I'm going to find the volume of this hole here, okay, inside the hole. So the volume of the hole, okay, the volume of hole can also be calculated with the formula the length times the width times the height. Now this time around, the length of it is 5 and the width is 3 and the height, definitely it will be the same height here, which is 7. And if you multiply this out, you're gonna have 105 centimeters cubed. Now we know the volume of the big cuboid and the volume of the whole cuboid. Then the volume of the steel has to be the subtraction of this from the big one. So I'm going to take this a little bit upwards so you can see what I'm going to do. So the volume of steel is going to become 504 minus 105, and if you do this subtraction, you got 399 centimeters cubed. And then now to find the density, or not the density, the mass, okay, the mass is given, but we know that mass is given as the density times the volume. Already we know the volume, which is 399, and the density has already been given to us here as 8 gram per centimeters cube. So I'm going to multiply the, the, the density, which is 8, multiplied by the volume of the steel, which is 399. And if I do the calculation, I'm going to have 31 3,192 gram, and that's it. That's going to be the mass of it in grams. I hope you enjoyed this video. Have a great day.